Good morning, Sioux High Earth Science students. This is Mr. McLeod again, coming to you with part 6 of our discussion of the atmosphere, and more specifically, talking about storms. Thus far, we've looked at thunderstorms and how they form, and forms of precipitation and forms of clouds. We know that thunderstorms form from cumulonimbus clouds. And we understand fronts now, and we understand convection inside the cloud and why that happens. So let's look at some extreme examples of storms that occur when cumulonimbus clouds form. And you see some examples of tornado pictures here in this opening slide. So let's talk more about tornadoes. Write in your notes that a tornado is a rapidly whirling, funnel-shaped cloud that reaches down to form a storm cloud that touches the Earth's surface. So it's a rapidly whirling, funnel-shaped cumulonimbus cloud that reaches down from a storm cloud to touch the Earth's surface. So that's a tornado. So let's talk a little bit more specifically about how tornadoes form. Okay, so write in your notes that the key to understanding any storm, but in particular tornadoes and even hurricanes, is that they need a constant source of energy. And that for the most part, this energy is provided by warm water, like you see here in this picture. So that warm water now, you see now here on the left-hand side, you see that warm water now is fed from the Gulf of Mexico. So again, closer to the equator, warmer water. Up here, this water would be relatively cold. And again, Pacific air, very cold. North Atlantic air, very cold, comparatively speaking. But South Atlantic and down here in the Gulf, this warms up quite a bit because of its relationship to the equator. Also write that most of the tornadoes occur in the southern, midwestern, and eastern U.S. because these states are so close to the Gulf of Mexico, which is a major source of warm water because of its proximity to the equator, and we just mentioned that. The heat in that water is what powers the tornadoes. The heat in water is what powers most storms. So even thunderstorms, if we happen to have a hot summer, we happen to is like, we haven't had a hot summer in a long time. But if by chance we have a hot summer and the lakes warm up around here, that increases the chance that there's going to be some thunderstorms. And maybe even a tornado if they warm up enough, because there's enough heat in the water to power a big storm like a tornado. Now, also get in your notes that tornadoes form when warm, moist air, remember moist is the key, moist air flows in at the bottom of a cumulonimbus cloud and moves upward. And also write that when that happens, a low pressure area forms inside the cloud. So this is our cold, or this is our low pressure area right here. So that warm air feeds now the cumulonimbus cloud, and a very low pressure center forms. Now this warm air is moving very rapidly, and this cold air is also moving very rapidly. Okay, next write that this warm air rotates as it meets winds blowing in different directions at different altitudes in this huge cumulonimbus cloud. Why in different directions? Because you got the collision now of this cold air dropping because it's dense and this warm air rising because it's not very dense, and that causes now an intense rotation inside this cloud. So it's the meeting of the warm and cold air inside that low pressure center. So let's put this explanation into 5 basic steps in the formation of a tornado and get those steps in your notes. In step 1, warm, moist air rises from the ground. Makes sense, right? And where does this heat come from? Right, warm water. Step 2, this warm air rising meets cold air now sinking, normally from a fast-moving cold front. That should make sense as well, and forms a vortex which is a descending column of that cold air. Now, in step 3, this vortex finally contacts the ground. Yes, where the warm, moist air is. Then in step 4, another updraft of warm, moist air rises and is now rotating because of these temperature differences and forms what we call a funnel cloud. And then in step 5, the tornado now spins at a higher and higher speed because it's being fed the energy by the warm, moist air in the ground. And as long as this energy on the ground lasts, the tornado continues to rotate and move. Write in your notes that eventually the cold front drains enough energy from the tornado that it dissipates or stops. So again, if we look at this map on the left, we see this rapidly moving cold front this way. That's what this blue line is. And here's our warm front with moist air in it. So we've got this thing moving like crazy this way into this warm front, and now energy being fed by the Gulf. And that is like a recipe for a tornado. So that warm air eventually will get moved out of there by the cold air, and the cold air eventually drains the energy from that tornado, and that tornado is what we call dissipates. Now, here's a really good look at what meteorologists call Tornado Alley. Write in your notes that Tornado Alley is an area of the United States that has a high frequency of tornadoes because cold, dry air moves down from Canada to meet warm, humid air from the Gulf of Mexico. And also write that 5 typical states in there are Texas. You see Texas here. Now, we're not going to name them all, but Texas, Oklahoma, Kansas, Nebraska, and Iowa are the ones with the highest frequency now of tornadoes. Now, tornadoes occur here over in these states, but these are the ones now that occur most frequently. So, a keen observer might say to themselves, isn't that where the Mississippi River is? Yes, it is. You have the Missouri River. So you have bodies of water now other than the Gulf of Mexico that can still provide the warm air energy necessary for tornadoes in these states. Okay, now we also want you to get in your notes that the Fujita Scale, you see it right here, the Fujita Scale, Fujita Tornado Damage Scale, also called the F Scale, or sometimes referred to as the Fujita-Pearson Scale, get all 3 of those on there because you might see them, is the scale used to rate tornado intensity. Also write that this scale is based primarily on 2 things: the damage tornadoes inflict on human-built structures and the damage it wreaks on vegetation like trees and crops. So those 2 things now dictated the original Fujita Tornado Damage Scale. So you can look at the typical damage here and you can see that it's mostly property, but sometimes it's trees, etc. So the original Fujita Tornado Damage Scale. The official Fujita Scale is determined by meteorologists and engineers after a ground or aerial damage survey. So that's how they determine whether it's an F0, F1, F2, F3, F4. If you've ever watched the movie Twister, and I'm hoping we're going to have time to watch it in class, it's one of my favorite movies. They have great shots in that film of an F5 tornado. You can see now an F5 is like at the top of the scale. So that movie's got some fantastic footage of some F5 tornadoes. Now, also write in your notes that the F scale was replaced with the enhanced Fujita scale called the EF scale. So enhanced Fujita EF scale. And it was replaced in the United States in February of 2007. And it was revised to reflect better explanations of tornado damage surveys. so as to align wind speeds more closely with associated storm damage. So it's a little bit more concentrated, and there's more detail now in the damage. So now it's not the F scale, it's the EF scale, Enhanced Fujita Scale. It also adds more types of structures and vegetation, and also expands the degrees of damage and better accounts for variables such as differences in construction quality. So if you live in one of those areas where tornadoes are frequent, that kind of construction information is very important. Okay, just as an FYI about tornado safety, and we don't have enough of them to really worry about it, but you see these terms all the time: tornado watch, tornado warning. So get in your notes that a tornado watch is an announcement that tornadoes are possible in the area, and to stay tuned to the radio or television for more information. Whereas a tornado warning is an announcement that a tornado's been sighted and to take shelter immediately. And finally, the safest place to be during a tornado, obviously a storm shelter, which we don't really build up here because we don't have that many tornadoes, but in the south they have them. And in fact, in the movie Twister, you're going to see them go to the storm shelter at the beginning of the year, or the basement, if you have one, of a well-built building. So those are the best places to be during a tornado. Okay, now let's move our storm discussion to hurricanes. Write in your notes that a hurricane is a tropical cyclone. Remember, they call them cyclones in the southern hemisphere and in the south. A tropical cyclone that has winds of 119 kilometers per hour or higher, and that most hurricanes form in the Atlantic, Pacific, and Indian Oceans. The Atlantic, Pacific, and Indian Oceans. Also write that in the western Pacific Ocean, hurricanes are called typhoons. So again, here you say hurricanes are called typhoons in the western Pacific. You know, you think that's weird that this would be the western Pacific, but if we move this way far enough, we get here. So we're moving west when we go in this direction, so we call this the western Pacific. And then hurricanes and tropical storms form here in the North Atlantic, but we're going to see that they're fed by energy from the water in the South Atlantic. And they're mostly called tropical storms in the Eastern Pacific, and we're talking about like around Hawaii and California, etc. Okay, now let's move on to how hurricanes actually form. Write in your notes that a hurricane begins over warm ocean water as a low pressure area that's referred to as a tropical depression. So over here on the left, you see tropical depression here. So it starts out as a thunderstorm, cumulonimbus clouds, becomes a tropical depression. Question: where do you think a hurricane gets its energy? If you said that a hurricane draws its energy from warm, humid air at the ocean surface, you'd be correct. However, write in your notes anyway. Let's look at the formation of hurricanes in a series of steps, and once again, get them in your notes. In step one, as the air rises and forms clouds, more warm, moist air is drawn into the system via convection, like you see here on the right. You see now convection here. Remember, we're over the ocean now. Step two is that inside the storm are bands of very high winds and heavy rains, because after all, this system starts like a thunderstorm. Then in step three, winds spiral inward toward the area of low pressure at the center, call it the eye, and begin to build speed because of the enormous size of the cumulonimbus clouds. So if we were going to make a difference between a hurricane and a tornado, we would say it's the size of the cumulonimbus cloud that actually forms. Not that the tornado cumulonimbus is small, because it's not, but relatively speaking, it's small compared to the size of the cloud that this hurricane forms in. All right. Now, it's grown this size because of the huge pool of energy we call the ocean. And the ocean feeds energy into the system as long as it stays over water. So typically an active hurricane season is a hot summer in the tropics. That heats up the water in those areas enough that it powers hurricanes. All right, just a brief word about hurricane names. Hurricanes are given names so I help identify them and track them as they move across the ocean. Typically, men's and women's names are used. One name for each letter of the alphabet except Q, U, and Z. That's kind of weird. World Meteorological Organization uses 6 lists in rotation so they get used over again. And the only time a new name is added is if the hurricane is very deadly or costly. If that happens, then the name is retired and a new name is chosen. Isn't that weird? I'm glad we don't live in Hurricane Alley. Okay, that's it for part 6. Sorry, I went a couple minutes over. Usually it's about 15 minutes. Now I'm at 16:14. But I wanted to finish hurricanes on this podcast. So take a picture of your notes. Send that picture to Moodle. Grab the study guide for part 6. Answer the questions and submit it when you're done. And we've got one storm left to talk about, and that is the winter storm. And then we'll be wrapping up the atmosphere. So I'll see you again in part 7. Bye.